Golden ratio. Myth or math? Is it a thing of sacred geometry and a rule that is hardwired into nature, or is it just a myth? Let's find out. Around 300 BC, Euclid wrote a book called the Elements. In it, he said, if we divide a line using a specific way, then the ratio of the whole line to its longer segment and the longer segment to its shorter segment will be exactly the same. He called it the extreme and mean ratio, but today we commonly know this as phi, or the golden ratio. It is exactly equal to 1.61 and then it goes on forever, like the button on pi. Later, a man named Fibonacci wrote a book called Liber Abaci, or just a book of calculations. This book was mainly aimed to accustom people with the Hindu-Arabic numerals. In it, there was a problem with the rabbits. There was a pair of rabbits, one female and one male. From the second month she is alive, she reproduces to have another pair of rabbits. And how many rabbits will you have at the end of 1 year if no rabbits die or get eaten? The answer was a sequence where you add the previous two numbers to get the next, the Fibonacci sequence. And at the end of 1 year, you will have 144 pairs. Now we are talking about the Fibonacci sequence in a video about the golden ratio, because the higher you go in the Fibonacci sequence, the closer the numbers are to 5. He never made this connection though. Johannes Kepler did. Yes, the same Kepler who found out how the planets move. People now claim to see phi in a lot of unexpected places, but it might be that a pattern recognition is playing a trick on us. If you set out to find phi in something like a large building, then in the many ways you can measure it, some are bound to be somewhere near phi. The Nautilus shell, which has become the icon of the golden ratio, is only true for some rare Nautilus shells that every time the spiral grows, it is in the ratio of phi. Now, if you are wondering what a Nautilus is, then here it is. Close to 1.61 is not enough. It has to be exactly phi. Let's take some other examples. For example, a pineapple. We can count these spirals that if we count are Fibonacci numbers, commonly 8:13, and within the Fibonacci sequence is phi. Now, if you are wondering where the spirals are, then if you are thinking how plants do this, then that is still being worked out by scientists, but it has to do with the newly growing plant parts repelling the old ones due to growth hormones. Math follows particular rules, but beauty we find can be messy, as we have our own perceptions. But who knows, if we look hard enough, then maybe we can find some order after all. Happy World Maths Day! Thank you.